Now that our game has real pressure, multiple turrets spawning all over the battlefield, I feel like our player needs a little bit more support. So in this video, we're going to work on a mechanic expansion. We have our overdrive system in place, and we can use it to generate a shield which will absorb projectile collisions. But once we run out of that overdrive, we're done. There's no way we can get it back. So in this video, we're going to put a system into place that allows the user to regenerate some overdrive through what we'll call overdrive pickups. Our pickups will spawn randomly throughout the battlefield, and anytime we collide with one, we will restore a set amount of our overdrive so that the user can continually generate their shield and hopefully survive longer. So let's head right to the computer screen and we'll dive right in. I've got my lesson 7 starter file open right here, and I'm just going to minimize vscode.dev and open that file directly from my file structure so we can see the changes that we are going to make. So here's the current state of our game. All right, so looks really similar, I think, to where we left off. We've got our ramp in place, our overdrive system is working, but like I said, there's no way to regenerate that overdrive once we've used it. So if I spam that spacebar key, I am out of overdrive, and that means my unit has been destroyed. All right, so we have to implement this brand new system, this mechanic expansion of allowing for pickups, power-ups, whatever you want to call them. So let's head back over here to vscode.dev, and we are going to hit Control F to bring up our search bar, and I'm going to type mission 1. Let's look at our first mission here on this lesson on the mechanic expansion of overdrive pickups. It says, number 1, we want to adjust the pickup system constants. So anytime we introduce a new system into our game, it's very likely that we will put some constants right at the top of our program. So if we look up here, if I scroll up, right, we have this student edit zone where it's safe to modify these constants. Think of these like knobs or dials for our game that we can fine tune and change until the gameplay feels just right. Maybe your player feels a little bit too small. Changes player radius. Maybe you want a little bit more overdrive. Change your max overdrive. Maybe the game needs to go on longer until it hits max difficulty. Change your ramp time seconds. But right now, we are all about our pickup system, right? Our overdrive pickups. So we have mission number 1. We are going to turn the dials on these pickup constants. Let's look at what we have. We have a pickup radius, which is currently set to 1. Well, that's a really bad radius. This is going to be the size of our pickups. Our pickups are going to be circular objects. So I'm going to set their radius to, let's do 15 and see how that feels. We also have a pickup spawn interval in seconds. So how many seconds do we want to have go by before we spawn a pickup? Right now it's set to 1 second. That's going to be way, way too many pickups. So I'm going to set it to, I don't know, 7.5 seconds, 7.5. And then how much overdrive are we going to restore per pickup? So if you look, what's our overdrive? Our max overdrive is 100. So I'm going to let's restore maybe like a third of it. So I'll do 33. All right, perfect. And so if we scroll down here, we're still in our student edit zone. Let's just look at what else we have. In our color palette, I now have some pickup body color, pickup core color. So if you look at like our core is going to have a lot of green, and FF is green. Well, actually, it's going to have a lot of green, a lot of blue, and a lot of red. This is probably going to be like some white color. And the body color, our red channel is 42, our green channel is D3, our blue channel is 9.2. It's going to be a lot of green with a little bit of blue. It's probably going to be like a cyan. So that'll look pretty nice. But you can change those colors if you'd like. All right, and if we scroll down just a little bit more, we have some gameplay variables, things that are going to be used throughout the scope of our game. And if we look, we've added 2 new gameplay variables. One variable called pickups, which is an array, a container that is going to hold all of these overdrive pickups that are spread out throughout our battlefield. And we know the power of arrays because it's going to allow us to loop over all of the pickups and do operations on every single thing that is in this container at once. And then we've got a pickup spawn timer seconds, which is currently set to 0. Awesome. Mission number 1, done. We have some familiarity with this new system now. So mission number 2 says, hey, we got to reset our pickups. we're going to reset the pickup variables on our game start to ensure that the pickups and timers initialize correctly. Because right now, right when we start our program, we know that what pickups was an empty array and our pickup spawn timer was 0. But what if we, died and then we wanted to play again? We want to make sure that if there's any pickups in that array from when we died, like maybe we died and there's 3 pickups still on the battlefield, they should not be there when we reset and play our next game. So we have to make sure that we clear all of that data in this function, reset game to defaults. So those 2 variables that we just looked at, we have to reinitialize them. Well, now I shouldn't say reinitialize. We have to set them back up for the start of a new game. So I'm going to take that array, pickups, and I'm going to assign it back to an empty array. We're going to wipe the container out. And then our pickup spawn timer seconds, right? And just a friendly reminder, if you start, because that's a long variable name, but I like descriptive variable names. I think it's helpful, especially when we're trying to learn and teach. If you start typing, and right here you get all these nice options, pickup spawn time right there. If you just hit tab, it will type it out for you. How lovely is that? So pickup spawn timer seconds. Well, I'm not going to set it to 0 because when we initialized it, we set it to 0, right? We initialized it way up here. When we defined the variables, we defined it as 0. But now the game is starting. So when the game starts, I want to set it to our timer value, because what's going to happen is I'm going to constantly count down. So what did I set the timer to? 7.5 seconds. So then it'll be 7, 6, 5, 4, 3, 2, 1, 0. And when it hits 0, that's when we'll spawn a pickup into our battlefield. And then we'll just reset the timer. So I'm going to set this to my constant pickup spawn. Ooh, and look at that. It pops up right here. I'm going to hit tab and it will auto complete it for me. Mission number 2, complete in the books. Nice job. Well, let's look at mission number 3. We need to generate our pickup data. See, right now we're just working on setting some constants. No power-ups are going to spawn here in the battlefield yet. We haven't done enough work. Remember, there's 3 phases to this whole process. We need to generate data, update data, and draw data. Right now, we're sort of working on the generate data, so we're missing 2 of the 3 key steps here. So let's look at mission number 3. Well, will you look at that? It's all about generating our data. We need to generate our pickup data. So it says complete the pickup data structure, define position values for each pickup. Well, let's look at the structure of these functions that we have in regards to our pickups. So I have generate pickup data. We have generate pickup data. We have spawn pickup, and then we have update pickup spawning. All right, so it's kind of very similar to how we had what? Our projectiles and our turrets. We had a generate the data function, then we had a spawn the object function, and then an update the function, or update the object function. So that structure you're going to see over and over again here when we make games. We're going to generate data for the object that we're spawning, we're going to spawn the object, and then we're going to update the object. So right here, what is it? It's returning our structure for our pickup. It looks like it has 2 properties. It has an X property and a Y property. And right now they are just set to 5, 5 and 5, which means every single pickup that we generate, that we create, is going to be at X position 5, Y position 5. Every pickup is going to be like right here. That's stuck in our HUD. That's going to be super bad because if you remember, I can't get into my HUD. My HUD, that movement is blocked off. So all of my pickups will be spawning out of reach. That is a terrible system. So what we're going to do is we are going to change the X and Y positions of our pickups when they are spawned. And I don't want them to all spawn in the same location, right? I don't want them to all spawn. I mean, I could put them at like, width over 2 and height over 2. Now they're going to spawn in the battlefield, but they'll always spawn in the same spot. That's not fun gameplay. We want to make it random. And so we are going to use the random function to randomize the location of where these pickups are spawning. And so inside here, there's lots of ways we can use the random function. The way that I'm going to use it is I'm going to give 2 values, A and B. And A is going to be a lower bound, B is going to be an upper bound, and the random function will pick a value somewhere between them at random. So I could do 0 and width, the whole width of our canvas, But what is likely to happen is that our pickups could spawn sort of off the screen, off the edges. So I don't want that to happen. So what I'm going to do is I'm going to take the pickup radius into account. So here, I'm going to add the radius of our pickup to shift it over into the right, into the battlefield. So 0 plus the pickup radius, well, that's just the pickup radius. All right, and then similarly, our width, it could spawn half off of the screen, so I'm going to subtract the pickup radius to bring it back over. So we'll do width minus the pickup radius. And then just in play testing, I don't like to spawn things directly on the edge, so I'll move them in just a little bit more. I'll do like a little bit of an offset of, I don't know, I'll do like 20 pixels. So this one I'll move it to the right another 20, and this one I'll move it to the left another 20. I probably could put those in a constant called like, pickup buffer. Maybe you want to do that. I'll leave it just here as 20 though, and know that that's going to be my buffer, my offset. All right, let's do something similar for our y value. So we're going to use random, and let's see, what are our random values going to be? Well, we could do 0 and height, but that's going to work really poorly for us because 0 is going to put us off, half off the screen and into the HUD. So we know we were going to have to add the pickup radius to shift it down, but then I also want to make sure I'm adding the HUD height to shift it down into my gameplay area where the player can actually move around. So we got to add 2 things here to our 0. So I'm going to say, okay, well, 0 plus HUD height is just HUD height. And then I'm also going to add in the player's radius to shift it down. And then let's also add in our offset of 20. All right, so that looks really great. And then what are we going to do for the height of the canvas? Well, the height all the way down here, there's a chance the pickup could spawn half off. So we're going to shift it back up by the radius. And that should take care of it. So we're going to do height minus player radius. Not player radius. What was I doing? It's pickup radius. Hopefully you caught that. So this one right here, I got to change this to pickup underscore radius. Excellent. And now, since we were putting that offset on every other position, let's also put that offset here. So I'll do minus 20. And I think that is going to look great. So we have successfully generated the data for our overdrive pickups. That's excellent. So step 1 is done. Remember, there's 3 phases to this. We got to generate the data. We got to update the data, and we have to draw the data. The data is now being generated. So what's mission 4 going to have us do? Well, mission 4, hey, look at that. It's all about updating the data. It says we are going to spawn our pickups into the world. Add a new pickup data into the pickups array. So let's see. This is in our update pickup spawning function. What are we doing? Well, we're taking our timer that we have and we're subtracting dt. Remember, our pickup spawn timer was what? 7.5 seconds. So we're subtracting time from that. And then we're asking a question. If that spawn timer is less than or equal to 0, meaning the timer has run out, it's time to spawn a pickup into our world. So how are we going to spawn a pickup? Well, if I scroll up just a little bit, I got a nice function here called spawn pickups, which takes our array pickups, calls the push method on it, which means put something at the end of that array. What are we putting at the end of the array? The stuff that gets returned to us from our generate pickup data function. And that's this object right here that we just created that holds an X property and a Y property. So our pickup knows exactly where it needs to go in our game world. All right, all we have to do in mission 4 is call spawn pickup. It will do all the work for us. But then there's one other thing we want to do, because our timer right here, right, is now basically at 0 or less than 0. It's going negative. So we need to reset the timer because I want more than one pickup to spawn into this world. So I will do pickup spawn, and then I'm going to hit tab to get the variable to complete, is going to equal, our pickup spawn timer is going to equal pickup spawn interval seconds. So right here, we'll hit tab to autocomplete it. So once it goes to 0, we spawn a pickup, and then we set that timer, we reset it back to our spawning interval of 7.5 seconds. So that's going to work. Awesome. Mission 4 complete. Hey, look at this. We got to mission 5 because right now we have done the process of generating the data, of updating the data, And I would wager that these pickups are in fact spawning. It's just that we don't see them because we're not drawing them. So we got to do that third and final part of the triangle. We got to draw the pickups. It says draw the pickups, render both the body and the core of each pickup. So in our draw pickups function, and let's just make sure, are we calling that here in our draw scene? So this draw scene, which we're running every single frame of our game, we are drawing the background, the turrets, the pickups, our projectile, our player, our HUD, our overlays, if we need them. So this is great. Our draw pickups is already going to be called. We're saying no stroke, which means give me an invisible marker so you don't see the outline of the shape that I'm about to draw. And then look at this. We're using a for loop to loop through our entire array for const pickup of pickups. So I am working with the individual object that is in that array, right? Maybe that array looks like this. Pickup 1, pickup 2, pickup 3. Well, when we loop through it, pickup will be pickup 1, then pickup will be pickup 2, then it will be pickup 3, and we will draw each and every one of those objects. So let's draw it. The first thing I'm going to do is I'm going to put some paint in my paint bucket. So I'm going to say fill, and I'm going to draw the body first. So I have a color for that, pickup body color. And now our pickup is going to be a circle. So we'll call the circle function. You got to spell circle right though. There we go. And remember, the circle function needs 3 pieces of information. The x and y coordinate of its center. So I'm going to do pickup.x. Our pickup has an x property, and I'll do pickup.y. Our pickup has a y property. Remember, we randomly are placing these in our battlefield based off of our data structure. And then we need the diameter. So my diameter is going to be my pickup radius that I've defined, and we'll multiply that by 2 because the diameter is twice the radius. All right, well, that's going to be the body. We also want to draw the core. So we're going to draw a smaller circle inside of the body. So I'm going to put a different color in my paint bucket. So we'll use pickup core color. And then I'll draw a circle. And it's going to be at the exact same location, pickup.x, pickup.y. But now our size, the diameter, is going to be much smaller. And I'm just going to make it pickup underscore radius. All right, let's see how this looks. So, let's refresh the page. Are we going to get our pickup spawning? So they should spawn at 7.5 seconds. So keep an eye on the time up here. And now, hey, we got one. Look at that. So that looks great. Now it does nothing, which is not good, but well, there's our next one. So I can't interact with them yet, but they are there. They're spawning, and that looks really great. All right, so I'm super, super happy with that. So now let's go to mission number 6. This pickup system is going great. Look at that. We said they're spawning, but we can't interact with them because we're not yet detecting collisions with them. So we got to look at mission number 6, which is all about collision detection. So we are going to detect player pickup collisions, check the distance between the player and each pickup. So if you look here, we are in this function called check player pickup collisions. It looks like we are looping through all of our pickups, but this is very different than the draw loop that we did, right? This doesn't say for const pickup of pickups. This is much more complicated. It says for let I equal pickups.length -1. I less than or equal to 0. I minus minus. Why do we have that odd looking structure here? Well, if you remember, this is the for loop structure we use when we want to remove something from an array. And if you think about it, when we have a pickup on the battlefield, if I collide with it, I'm going to want to remove that pickup from the array. Once I collide with it, they're called pickups for a reason. Boop, I'm going to pick it up, and it should no longer be on the battlefield. And so we use this notation anytime we want to remove something from an array. Well, what are we doing here? Well, we're reaching into that array and grabbing an object at position I and calling it pickup. So now I have this variable to work with. And look here, we're getting a dx, the distance between the pickup and the player in the x direction, a dy, the distance between the pickup and the player in the y direction, and then we're calculating something called hit zone. So we're going to use this information to try to determine whether or not a collision has occurred. Right now we're saying if false. Well, that question is always going to be false. It's never going to be true. So what we got to do is we got to ask a question right in here that is sometimes true, sometimes false. And the question is, are we colliding with a pickup? Now, we've actually looked at this math before because where are we? look at this. If we look at our check player projectile collisions method, so another collisions method, we did the exact same thing. We have dx, dy, and hit zone. Dx, the distance between our projectile and player. Dy, the distance between our projectile and player in the vertical direction, and hit zone. And then we had a nice check to see if the player got hit by the ball. Dx squared plus dy squared is less than or equal to hit zone squared. That exact same logic, that exact same math is going to hold true down here for our check player pickup collisions. But let's quickly just review that math in case you're a little rusty. So I'm going to come over here to the whiteboard. So imagine right here I have my, here's my pickup. Zoop. Here's my player. Okay, I'll make them bigger so you know that that's my player. And so right here we have a dx, how far away we are in the x direction. And right here we have a dy, how far away we are in the y direction, dy. The Pythagorean theorem says, hey, a squared plus b squared is equal to c squared. What are a? What is A? A is this side of the triangle. What is B? It's this side of the triangle. And what is C? C is the actual distance between these two objects. This is C. All right. Now, we can solve for that by saying, all right, so that means C is equal to the square root of A squared plus B squared. And I think we were calling this like the length, right? The length between these two objects. And so I can say the length, we'll substitute everything in, is the square root of dx squared plus dy squared. So that's really great. Now, how do we know when a collision occurs? Well, if the player is over here, the collision has not occurred. If the player is over here, a collision has not occurred. But if the player overlaps with that pickup, then it has occurred. So let's zoom in, right? Here's our player. Here's our pickup. The next instance of this, we know a collision has occurred. Well, if you look, the player has a radius, r1. The pickup has a radius, r2. And it's this distance right here that we refer to as our hit zone. Now, one of the things we can say is if the distance, the length between the player and the pickup is smaller than the hit zone, right? If the length is smaller than the hit zone, then we pick it up. Or we can even say less than or equal to. Then it's a pickup. Give us power. Power us up. But the length uses a square root. And we don't actually have to use the square root because we can actually square both sides. So I can just say, hey, if I square this side and square this side, what you do to one side of an equation, you can do to the other. So this holds true. So I can actually just look at, let me erase this square root. We'll get rid of this square root. Zoop, 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 zoop. And I can say length squared. So our check here is going to be, is dx squared plus dy squared less than or equal to hit zone squared? If that is the case, it is time to power up. So thank you for coming to my math review here. Hopefully that was helpful. Always like to make sure we fully understand the math that we are working with. So let's put that question right into play here in mission number 6. We are going to say if dx squared plus dy squared is less than or equal to hit zone squared, then what are we going to do? It means we have collided with a overdrive pickup. So look at mission 7 right here. It's our next thing right below. We want to restore overdrive when collecting and increase the resource based on our restore amount. So remember the player, we've got an overdrive variable that's keeping track of how much overdrive is in our system. Overdrive. So I'm going to add to it plus equals to increment it by a set amount. I'm not going to increment it by 5 or 10. Instead, we have this value stored in a constant variable that we looked at the beginning of this video called overdrive right here, restore. Overdrive restore per pickup. I believe it's like 35 maybe. So let's test this out. So now I'm going to use a little overdrive. Awesome. So my overdrive is going down. And now we should have collisions. Boom. Awesome. We get rid of them once we have collided with them. So that's really great. And it restored my overdrive. Boom. Whoa. It looks like I went beyond the bar though. So this is not good. It looks like we can get more overdrive than possible. So we somehow have to cap the overdrive so that we don't go past it. And if you look at mission number 8, overdrive clamp. That's what this is all about. We're going to prevent overdrive from exceeding its maximum value and clamp it within our valid limits. Now, look here. Ooh, look at this. The line for splicing from our pickups array, anytime we collide with one of those power-ups or one of those pickups, we're removing it from the list, which is why it disappeared. That's great. We saw that in action, but we did not see this clamp in action. So let's put it in. So we're going to take our overdrive variable and we're going to constrain it to two values. So remember, constrain takes three pieces of information. It takes the value that you want to constrain, which is our overdrive variable, and then its minimum value. The minimum value here is going to be 0, and its maximum value. Well, our maximum value, I think we have a constant variable. Isn't it called max? Yeah, it's called max overdrive. We've set this to be 100. So we have this variable. This is our maximum cap. Now with this system in place, we should be good to go with a fully operational mechanic expansion system of overdrive pickups. Let's test it out. So I need to use my shield. There we go. I need to use it again. Boom. I didn't need to use it, but all right, now I'm going to pick this up. We restore. All right, very good. So you can see I only got a little bit left. Let's go see. Okay, so the spawning system's working nicely. If I pick this up, it should constrain. Yep, and it caps me right there. So now, ooh, there's a nice pickup. That's risky to get, though. All right. This is working much better. Now, see, right now I'd be in a lot of trouble if I didn't have these pickups, but I can refill. Awesome. So this adds a level of strategy now. You can conserve your overdrive. You can use it when needed, when you need help, to leverage it to survive longer in the game, because you know that there's now a system that you can use to bump that overdrive back up. I also like how sometimes the overdrives are a little risky, right? They're spawning randomly over the board. There's a chance they could spawn right near a turret or partially on top of a turret, which means you're going to have to get extremely close if you want that. It sort of balances that risk and reward system that is really fun when you're playing a game. So this is a great place to stop, and I'll see you in the next video.